Hi class, today we are doing our triangle theorems part 1. So take out your packet that correlates with this so you can jot down the notes as we go along. Okay, the first part of your notes are classifying triangles by the types of angles. Okay, first one we have is an acute angle. The acute angle is a triangle with all acute angles. Remember, flashback to a couple years ago when we talked about acute in your 8th grade classes? That means all less than 90. So make a little note there. That's less than 90 degrees. Okay, for an obtuse triangle, a triangle that has one obtuse angle, so that means one of the angles is more than 90 or greater than 90. Then there's a right triangle, a triangle with one right angle, so that means that's exactly 90 degrees because that's a right angle. Looking at these pictures, you have one of each type. This one here, all these angles are less than 90, so this would be the acute triangle. Okay, these are all less than 90. This one here, this angle here is bigger than 90, greater than 90, so this would be the obtuse triangle. And then this one, we're going to consider this a right angle, 90 degrees, so this would be a right triangle. As always, pause the video if you need more time to write anything down. Okay, next you can also classify triangles by side lengths. Okay, 3 different types of triangles here. First, you have equilateral triangle. Equilateral triangle pretty much has the word equal in it. So it's a triangle where all sides and angles are equal. Okay, all of them. Next, an isosceles triangle is where 2 sides and 2 angles are equal. Okay, so this one's just 2. Scalene triangle is where none of the sides and none of the angles are equal. Then you have your pictures there, scalene, so see how nothing's marked up? That means nothing's congruent. Equilateral has these dashes here, meaning they're all congruent. Isosceles, only 2 dashes, so that means only those 2 sides are congruent. Next, one of the first theorems about triangles is the fact that the sum of all 3 angles in the triangle is equal to 180 degrees, which again means supplementary. Okay, we learned that back with our lines. Okay, so in this example, angle 1 plus angle 2 plus angle 3, all of those equal, and they add up to 180 degrees. We're going to look at an example on this. Okay, so our first example is what is the measure of the largest angle in the accompanying diagram? In order to figure that out, we need to find x. In order to find x, you're going to have to use the fact that the sum of the angles inside of a triangle add up to 180. So you have the 2x plus 1, the x, and the x plus 15. So all 3 angles have to equal 180 degrees. Once you have that, you could flash back to algebra, do some math here, combine like terms. You have 2x, 1x, and 1x, so you'd have 4x. Then you have a constant of 1 and 15, which makes 16, still equals 180. From there, you're solving for x, so you want to isolate x, which means you want to move the 16 over. So you would get 4x equals 164. then divide by 4 to get x completely alone, and you would get 41 degrees. It is not looking for x, okay, so don't circle that answer. You now need to figure out what's the largest angle. So you would go plug all of the x's back in here. So this angle would be 41 degrees since it's just x. X plus 15 would be 41 plus 15, which makes this 56 degrees. 2x plus 1 would be 2 times the 41 plus 1, which makes it 83 degrees. Okay, a quick check would be adding these angles up, making sure they add to 180, which they do, so we're good there. And then it's asking for the largest angle out of the 83, the 56, and the 41 would be the 83. So the measure of the largest angle would be 83 degrees. Okay, next we're going to do one more example on this. It says triangle PQR has angles in the ratio 2, 3, and 5. So 2 to 3 to 5. Which type of triangle is triangle PQR? If you want to sketch a picture, you can sketch a picture. So we can draw a triangle, label it P, Q, and R. Since they go in order, so PQR, the 2 would be the P, the 3 would be the Q, the R would be the 5. So I'm just going to label that. So the P was the 2, the Q was the 3, the R was the 5. Okay. It does not make sense for it to be 2 degrees, 3 degrees, and 5 degrees because that doesn't equal 180. Okay, so just like when we did ratios back with our angles, okay, remember you have to put an x with each one of these. So this is 2x, 3x, and 5x. Then you have to use the fact that those 3 angles inside your triangle have to equal 180 degrees. From there you're going to solve, so you're going to combine like terms. You have 2x, 3x, and 5x, which makes 10x, equal to that 180 still, divide by 10, and x would equal 18 degrees. Again, that's not your answer. In order to figure out what type of triangle, we actually need to plug that 18 back in to the 3 angles that we have. If we plug that back in, 2 times 18, this would give you 36 degree angle. 3 times 18, this would give you a 54 degree angle. 54, make sure that's a 54. Then the 5x would give you 90 degrees here. Because there's this 90 degree angle, it makes it a right triangle. Okay, hopefully we're okay with that. Obviously, when we get into class tomorrow, if you're confused, we can go over any questions there. The next theorem I want to address is called the exterior angle theorem. Exterior means outside. Okay, so exterior angle of a triangle is equal to the sum of the 2 remote interior angles in the triangle. And there's 2 more sub-definitions because we have to know what remote interior angles are. Those are 2 angles non-adjacent to the exterior angle. And the exterior angle is the angle formed by extending a side of a triangle. Here's a picture here. Okay, the exterior angle would be angle 4. So the exterior angle of a triangle, so angle 4, is equal to the sum of the 2 remote interior. And then remote interior means 2 angles non-adjacent, which means not next to. So we do not want to be next to angle 4. If we're not next to angle 4, we're looking at angle 1 and angle 2. Sum means addition. So our theorem here would be angle 4 equals angle 1 plus angle 2. Once you have that theorem down, we're going to do an example. The example says, in the diagram of triangle ABC below, AB is extended to point D. If the measure of angle CAB is x plus 40, and the measure of angle ACB is 3x plus 10, and the measure of angle CBD is 6x, which are all labeled there for you, what is the measure of angle CAB? So we need this angle here. In order to figure out that angle, we need x. In order to figure out x, we need to use the exterior angle, because that's what we're given. So remember that theorem we just wrote down says the exterior angle, which in our case is 6x, equals the sum of the two remote interior, which is that 3x plus 10 plus the x plus 40. From there, you're going to combine like terms on your right-hand side. You would get 4x plus 50. Make sure it looks like a 5. Okay, from there you're going to solve. So you're going to get x's on one side. So you're going to move the 4x over. So you'd get 2x equals 50. Geez, again, make sure that 5 looks like a 5 and not a 6. Divide by 2, and x equals 25. From there, you want to actually go plug x back in. So you'd have 25 plus 40, which makes this angle CAB equal to 65 degrees. And that would be your answer. Hey, remember, as always, that is the end of our little mini lesson before I see you tomorrow. Okay, so make sure all those notes are jotted down. You have some example problems. If you always want to research more, you're welcome to. But other than that, I will see you tomorrow. Have a good night.